Let us consider the concept of marginal rate of technical substitution. In the previous video, we have drawn the isoquant curve. Isoquant curve, how we have drawn? We know that the isoquant curve is the locus of all input combinations or various input combinations that give us the same amount of output. And in our previous example, the amount of output was 26. Now, when we have drawn the isoquant curve, we have measured the labor on the x-axis or on the horizontal axis and the units of capital on the vertical axis. Now, look at the combinations of the factors. Suppose we start with the point A. If we consider point A, we can see that 18 units of capital was engaged with 6 units of labor to produce 26 units of output. Now, here if we increase the labor by 1 unit, means here from 6 to 7, this is the increase in labor. Now, to increase in labor was happening here by 1 unit. Look at the change in the capital unit. How much capital we have sacrificed? Sacrifice the capital or the change in capital. We can denote the change by del K. And this amount was 18 minus 12. 6 units of capital basically we have sacrificed to increase 1 unit of labor. Now if you look at here we have sacrificed del K units of capital, which is 12 minus 9, or we can write it as 3. That means here the change in del L, the change in labor, is equal to 2 units. Here we have changed the labor by 2 units but sacrificed only 3 units of capital. Now if we move from point C to point D, what is the change in labor? Change in labor we will denote by del L. What is the change in labor at here? Change in labor at here is basically 12 minus 9. That means 3 units of labor we have changed here. And look at the amount of sacrifice. We have sacrificed the capital only by 9 minus 7 or 2 units. If we look at the changes, we can see here it is for A to B. For A to B, if we measure the change, rate of change, then it will be del K by del L. So 6 by 1. For B to C, when we moved from B to C, the change will be del K by del L, which is 3 by 2 units. And if you look at C to D, the change in capital divided by the change in labor will be 2 by 3. So what we can see here? We can see here that if we continuously increase the labor unit, there is a little scope or less scope to sacrifice more and more amount of capital. So from A to B, when we moved, this ratio, this was 6 upon 1. That is equal to 6. Now 6 is definitely greater than 3 by 2. 3 by 2 is the ratio when we move from A to B. This is the ratio when we move from B to C. And if we increase the labor furthermore, that means we are moving from C to D, what will happen? This ratio is 2 by 3. Even it is lesser than 1, although when we move from B to C, the value of the ratio was greater than 1. That means as we move from left side to the right side, we are continuously increasing the labor. The capital with which this labor will work, that is continuously decreasing down. So we have lesser scope to sacrifice the capital. We will be ready to sacrifice lesser and lesser amount of capital to employ more and more amount of labor. The ratio between these two changes, the change in capital and the change in labor, we also can name it as the marginal rate of substitution or MRTS. MRTS means what? That how many labor can be substituted for decreasing amount of capital. So what is MRTS? MRTS is the loss of certain amount of capital that will required to compensate for the additional units of labor at that particular point. Or in other words, we can say that the marginal rate of technical substitution of labor for capital is the slope of the isoquant at that particular point, because this is the formula for the slope as well. This MRTS, basically we can also explain it alternatively. For example, if we move from A to B, in this example, if we move from A to B, some amount of labor we are engaging, or we are increasing the amount of labor, and some amount of capital we are sacrificing. Let us denote the change in labor by del L and change in capital by del K. Now, if we increase the labor unit, if we increase labor by 1 unit, how much amount of output we will get? That will be reflected by MPL. So, if we are increasing or changing the labor by del L unit, then definitely how much amount of output will be changed? Output will be changed by MPL into del L units. So, we can expect the change in output by MPL into del L units. If we change K by 1 unit, then output changes by MPK units. So if we change del K units of K, then the total change in output due to change in the capital will be MPK multiplied by del K. So it will be del K multiplied by MPK. So in this case, this is the change in output, change in output due to change in L, and this is the amount of change in output due to the change in K. Now if I take the sum of these two changes, then that must reflect the total change in the output. If we are considering that both A and B are on the same isoquant curve, then this del Q will be equal to 0, which means this del L multiplied by MPL plus the del K multiplied by MPK, these two things will be equal to 0, because we are on the same isoquant curve, that is producing 26 units. So in this case we can write here del k multiplied by mpk, which is equal to del L multiplied by MPL, or we can write here that del K by del L is equal to minus MPL by MPK. So this del K by del L is the MRTS, or marginal rate of technical substitution. This technical part is coming from the technology, what we are using, how much it is feasible, how the technology that we are using in the production process, how it is permitting the producer to substitute one input by the other input. So this is the marginal rate of technical substitution. Marginal rate of technical substitution is the slope of the curve, as well as this is nothing but the ratio of the marginal products of the factor inputs.